Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey, Ms. Lindsay.
Hey, Mr. Bergman.
It's awesome to be here. We're going to talk about minerals, and you're like the expert. You're the mineralogistic expert. Is that a word? I don't know. I made it up.
They do rock me.
They rock you. That's awesome. That's awesome. They rock her. Awesome. Okay, so what the heck is a mineral? I'm like confused. Is that a rock or a mineral? I think there's like a difference, right? I mean, what's
definitely.
the difference?
Definitely a difference. If you think back to chemistry.
Chemistry, okay, yeah.
Minerals are really just compounds.
So a mineral is a compound.
Yeah, it's just one compound.
One compound.
One compound.
Like salt.
Like salt, exactly.
So salt is a compound, and salt's a mineral?
Salt's a mineral.
Oh, that's cool.
Pretty important one for life, too.
All right. What are some other examples of things from chemistry that are minerals?
Well, simple elements like gold.
Oh, gold. Oh, I've got a gold ring on right here, Mrs. Lindsay.
That's pretty. You got a mineral.
So I have a mineral on my hand.
You do.
Wow. So, but there's lots of compounds. Now, I'm a chemistry guy, and there's like thousands and thousands of compounds, actually millions of compounds. So it's actually only certain kinds of compounds, right, that are minerals.
Exactly.
Yeah, what kinds of compounds, typically?
Well, we have compounds that are called silicates.
Silicates.
Those are pretty complex.
I think that comes from the word silicon, the element Si,
It is.
right?
That's in there, yep. And then we have some feldspars.
That's a funny word. That doesn't sound like chemistry, though.
No, that's a very complicated compound that geologists really like.
They like it a lot. Okay. So, but isn't it that it's like ionic compounds mostly, right?
It is. It's very ionic.
So you recall back to chemistry land, that is metals bonded to nonmetals, and most minerals, not all, my gold is a metallic bond, but most of them are ionic bonds.
Exactly.
Okay. Now, rocks and minerals, they're not the same like beast, are they?
No, not quite. Rocks are actually lots of minerals together.
So they're like mixtures of minerals.
They are like mixtures. And there's a word called aggregate.
The mixtures of minerals, but the fancy word is what?
Aggregate.
Now, I've seen that beside the road. Aggregate. I might have misspelled that, folks, wrong. But aggregate is that's like the cement companies. They are aggregate companies.
Exactly.
Right? Because cement's kind of like a bunch of rocks cemented together. And a rock is minerals cemented together. Oh. So all rocks have minerals.
Exactly.
But all minerals don't have rocks.
Have rocks.
I see. All right, we're learning a lot here. Is it a rock? Is it made up of an aggregate of minerals or compounds? Of course. So that they're minerals, and a mineral is a compound like an ionic compound. Minerals are single compounds. All right, you already said that. This is awesome. And here's a picture. Oh, look at that. Quartz. So quartz is a mineral.
Quartz is a mineral.
Hornblende, whatever that is a mineral. And, feldspar. That's that funny F word that you...
Feldspar.
The F word. The feldspar. But this is a rock. Hard to see behind all the writing, but it's granite. Does that have a mixture of all those three? Is there some feldspar, some hornblende, and some granite in there?
Looks like it.
Oh, I see. The granite. I bet many of our students might have granite counters maybe at their house or something like that.
They might.
And those are mixtures of minerals. Oh, that makes total sense. All right, so that's so cool. So minerals are awesome things. And what do we know about minerals?
There's a lot of them. There are about 4,000.
4,000 minerals. Okay, so that's not a huge number. It's big, but not like crazy, right? So there's 4,000 different minerals. Assume on the Earth. Are there other ones up in space?
I would assume there might be.
Different ones? Okay, but
so.
all right. So
I haven't been out there and checked it out.
It is an Earth science class, so we can say on Earth. Maybe there's more up there. Okay, example is gold. All right, what else do we know besides 4,000 different minerals?
Well, they're pretty important. They've shaped everything.
Shaped the world. Right?
Yeah.
Okay.
Not just and everything that we've done with the world as well. Like you mentioned with concrete, we can't build stuff without minerals.
So everything is made out of minerals.
Everything's made out of minerals.
Except for like living things, right?
Exactly.
So this is a non-living thing. So all non-living things I once took a class years ago, and they said it's either farmed or mined. Right, so farmed is, of course, for the that's the eating and bio stuff, and we're talking about the mine stuff, the stuff that we dig out of the ground and we use for our world. So minerals have some characteristics, right?
They do.
So what are they? What's some characteristics?
Well, they have to be naturally occurring.
Okay, so they're naturally occurring. Oh, what did I just do? I killed the pen.
So man can't make them. Not man-made.
So not man-made.
Not
man-made. Okay. What else?
They need to be inorganic.
Inorganic. Now, I'm a chemist. I know what that means, but can you help us out? What does that mean for our students who aren't like chemists?
Well, we know IN prefix means not.
Not
and
organic.
Organic means
So
living.
organic means living, so not living. We
No.
just talked about that a bit ago, right? Not living. Okay. So these are chemicals that aren't alive.
Exactly.
But there were some that were alive.
It gets complex with
Okay.
very few of them.
And
yes.
there's one third one, I think. What's the third thing?
Third thing is that they have an orderly crystalline structure.
Ah, okay. Now, what does that mean? An orderly crystal. I like crystals. Those are cool.
Crystals are cool.
Yeah.
It really just means the particles or atoms are stacked together in a very specific way.
So it's like a pattern.
Mm-hmm.
So, and the patterns can be kind of cool to see. All right.
Absolutely.
What else?
Well, they're definitely going to have some kind of chemical makeup to them.
So chemical. Again,
It's very specific too.
but each mineral is different chemical makeup.
Very different.
So, for
yes.
example, I happen to know that this chemical, now if you guys remember at Chemistry Land, this is calcium sulfate. That's probably how you learned it in Chemistry Land, but it's used very commonly, and we've got lots of it around us. What's that?
That's in geology speak called gypsum.
Gypsum. And gypsum is used for what?
Gypsum can be used for a lot of things, but the big one is drywall.
Drywall is made out of gypsum. That's that fine white powder, etc. So this is a chemical, calcium sulfate. We call it gypsum in the geologic world, but it's a chemical that's useful, and it's a mineral, and it's mined. Okay,
Yes.
cool. All right. What about this? So let's get back to this crystal structure piece. Tell me more about that.
Well, crystals, it comes, if you go back to your chemistry, you have to have atoms,
Mm-hmm.
and they need to be arranged in a specific pattern, and there are lots of different patterns that they could be.
Folks, this is really important to understand. What's going on here is that, like if I have a salt crystal, okay, you've got sodium chloride, and they form, in this case, actually like a cubic arrangement. I'm going to attempt to draw a cube here. And they form this pattern, and then what you see on the crystal is it looks like a cube.
It does.
Of all things.
Oh, that's pretty good drawing.
So, yeah, thank you. And so here we have some different options here. Look, so we can see cubes. I tried to draw the cube there. We've got the octahedral. Those are cool when they're that shape. And then blades. I haven't heard that one before. And hexagon. So lots of different shapes that they have. So do all minerals have these like cool, awesome shapes?
Not when you look at them in the naked eye. If you could look at them in a microscope, though,
So you need a microscope. Okay.
Yeah.
All right, that was a bad microscope. That was an attempt at a microscope, people. All right, if a crystal forms, what?
Without being restricted, without restriction.
So like I say, in an open space?
Yeah.
So if it opens, it probably forms in an open space, is that when you can get cool crystals?
That's when you get the cool ones.
Equals, that's how you get the large, and you've probably seen pictures of large crystals. We'll show some in a minute here. All right, so crystal forms for large, and then what's the next thing? We can have, that's cool, look at that picture right there. All right, squirrel, Mr. Redwing just saw a squirrel. All right, well-defined crystal shape is what?
They're pretty rare.
Okay, so seeing these cool crystals is rare.
Yes.
Now maybe if you go to like some of the museums, they collect the super cool ones. And then you get to see them. I got a chance to go to like the Smithsonian. I saw the Hope Diamond. That was awesome. And that's a very rare crystal. It's quite large.
Very
right?
rare, yes.
Very rare. All right, and it grows. But most of the times they are if they grow in a restricted space, a small space,
Yes.
then sometimes it's hard to see the shape, right?
Right.
If restricted. Okay, good. All right. And then we have a cool picture here. Tell us about what that picture is.
Well,
right
that's
there.
also halite, just like the picture above it.
Oh, so this is halite, but by the way, halite is salt,
Yes.
sodium chloride, and that's halite too. But it grew in a restricted space, and so we'd need a microscope to see the cubic nature of the crystal. Ah,
Exactly.
I see. Okay. All right. Well, let's take a look. Let's take a look at some crystals and take a look at them. Should we do that?
Absolutely. Let's go on an adventure. We've got some crystals here. You'll notice they have different shapes.
Oh, so that one's got a weird shape. I can kind of see that one. This one has, okay, cool shape. This one looks kind of that's like awesome. It's like a flower, right?
It is like a flower.
And then this green one has an interesting shape. So these are all pure chemicals. But then if you look at this one doesn't have any crystals that I can see.
They're very tiny. That's where you need to pull out your magnifying glass.
Oh, need the magnifying glass or the microscope or whatever. And that one's like crazy flat right there. Look at that.
That's super flat.
Awesome. All right, we'll learn more about how to distinguish these a little bit later, right? So can you tell me some more about minerals? We've got a big picture here, right? Variations in composition, a lot of words here. Help me out.
So chemical composition, the chemical makeup, the compounds, they can be very similar, but then they can be just a little bit different. And this is where the geology produces some really neat minerals.
So they can be very slightly, the chemical composition, and then they can look way different.
Yes.
So we've got this thing called plagioclase.
Close?
Plagioclase.
Plagioclase.
Feldspar, and these are both that's blue, and this one's like orangey.
Yeah.
So,
And
but they're the same thing.
They're the same thing. They crystallize at a little bit different temperature, and minerals elements crystallize at different temperatures, some at low, some at high.
So the difference between this one and this one is they crystallized at different temperatures, but they're made up of the same ball game.
Yes.
Weird. Okay, what about this one? Same thing?
This is the same thing.
That's the same thing
That's
these.
That's basically the same thing. Seriously.
So it's made of the same chemicals, but so this one, is it different temperatures? Like 3 temperatures, or it's something different?
3 different temperatures.
Okay.
Yeah, the first one, the pinkish, orangish one, was a low temperature.
So low. Is this the medium one?
That was a medium temperature.
Oh, and this was hot.
Yep.
Ah, okay. And you're not going to know this, folks, which is which.
No.
But a rock, or pardon me, a mineral can look way different, but still be the same chemical composition. Is it the same mineral? They're all feldspar.
Exactly.
Plagioclase, something.
Plagioclase feldspar.
Plagioclase feldspar. All right. See, I tell you, she's the expert.
One of my favorites.
All right. So her favorite. I've got to know how to pronounce it, obviously. All right. Minerals, they come from magma. I love this word.
Yeah, that's
cool.
one place for them.
What's
Magma's
magma?
awesome. Magma.
What's magma?
Molten rock.
Molten rock, and it's important to say it's molten rock underneath the earth.
Exactly.
Molten rock on the earth we call lava. So it's happening under the earth, so liquid rock under the earth. All right.
I love that description.
I love that. Ooh, that's awesome. Ooh, that's awesome. All right, so the rate at which magma cools determines the size of the mineral. So if you want big crystals, it needs to cool slow. If you want small crystals, they cool quick. That makes sense.
Exactly.
Okay. And I think, tell me if I'm wrong, this is Mr. Bergman's memory on this, the slow ones typically happen deeper under the earth.
Exactly.
So the deeper the earth, the larger the crystal. So if I want like a big diamond, I got to dig deep.
Very deep.
Like really deep. Okay. In fact, actually, if you go to the mines of South Africa, they're very, very deep. The diamond mines.
They're like 10 miles down.
Are they 10 miles? I didn't know they were that far.
Or maybe a mile.
Wow.
It's really deep.
All right. All right. And minerals are often what?
Minerals are also often dissolved in water.
Oh, okay.
Those ionic compounds, if you remember your chemistry, ionic compounds dissolve in water.
Okay, so some dissolve in water, and then they come out of solution, right?
Yes.
So these are like this picture right here, right?
Exactly.
So they're sort of as they evaporate, they turn into minerals. Okay, so a lot of the caves you've ever seen, the stalactites and the stalagmites, that's what you see them, and these are called what?
These are called evaporites.
Well, that makes sense.
'Cause they-
ITES. Yeah, they evaporate, so they're evaporites.
exactly.
Did I spell that right? Evaporites. Okay. So the evaporites are ones that come when the water evaporates and turns into things like what we're seeing in this picture from Yellowstone Park.
Right, they get left behind, and
That's
then
awesome.
you can see them.
Okay. Hey, anything else we need to learn about minerals?
Not in terms of what they are, but
All right.
we're going to learn some things about properties.
Oh, we're going to learn how to figure out which one's which.
Yeah.
Oh, that's coming up next. We'll see you in class.